Here is the full proof for the third angle theorem. Congruent triangles. Theorem. Two triangles that are congruent are also similar. Given that triangle ABC is congruent to triangle PQR, prove that triangle ABC is similar to triangle PQR. Since triangle ABC is congruent to triangle PQR, we know that angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R, because corresponding angles are congruent. Since three pairs of angles are congruent, triangle ABC is similar to triangle PQR by the angle-angle similarity theorem, QED. Congruent triangles are therefore a special case of similar triangles. We will focus on similar triangles first and then work more with congruent triangles in a later unit. Note, the converse of this theorem is not true. Side-side-side similarity theorem. Book 6, Proposition 5. If two triangles have their sides proportional, the triangles will be equiangular and will have those angles equal which their corresponding sides subtend. Triangles with three pairs of congruent angles are similar, so this is Euclid's way of saying that triangles with proportional sides are similar. Here is a modern way of saying the same thing. If three pairs of sides in two triangles are proportional, then the triangles are similar. Note, we include a rigorous proof of this theorem in the appendix with a link to an online video explanation. If three pairs of sides in two triangles are proportional, then the triangles are similar. So given triangles ABC and PQR with side lengths as indicated, prove that those triangles are similar. Alright, so it's given that these are two triangles with these side lengths of 3, 4, 5 and 6, 8, 10. It's an arithmetic fact that 3 over 6 equals 4 over 8 equals 5 over 10. All of those are 1 over 2 when simplified. Property of proportions says that we can write this like this. 3 to 4 to 5 equals 6 to 8 to 10. Substitution property says that we can then replace these numbers with the line segments themselves. So instead of 3, we would write AB. Instead of 4, we would write AC. And instead of 5, we'd write BC. And then here, instead of 6, we would write PQ, and then PR, and then QR. So that's substitution property. Therefore, due to the SSS similarity theorem, triangle ABC is similar to triangle PQR. Here's another example of a different proof. So given the two triangles here with side lengths indicated, prove that these two triangles are similar. Alright, so we begin with our given information. The segment addition postulate states that this segment here plus this segment here equals the full segment. So PS plus SQ equals PQ, and the same for down here. PT plus TR equals PR. And then because we know that the length of PS is 3 and the length of SQ is 6, we can substitute in these numbers instead of just these segments here. So then we set those equal to the same values, PQ and PR. We can do that addition, and that's an arithmetic fact. And then also, this is separate, but this ratio here, so 3 over the full length, which is 3 over 9, equals 4 over 12, equals 6 over 18, which is 6 plus 12. That's another arithmetic fact. We can write it like this, because that's the property of proportions. We can then substitute in the segment names here instead of just the lengths. And therefore, because of the SSS similarity theorem, we know that the two triangles are similar. Side-angle-side similarity theorem. Book 6, Proposition 6. If two triangles have one angle equal to another, and the sides about the equal angle are in proportion, the triangles will be equiangular and will have those angles equal which the corresponding sides subtend. Triangles with two pairs of proportional sides and congruent included angles are similar. Here's a modern way of saying the same thing. If, in two triangles, two pairs of sides are proportional and their included angles are congruent, then the triangles are similar. Note, we include a rigorous proof of this theorem in the appendix with a link to an online video explanation. Here's a proof for the side-angle-side similarity theorem. Given triangle ABC and triangle PQR with side lengths as indicated, where angles A and P are right angles, prove that the two triangles are similar. Alright, so we're given the two triangles with side lengths. It's an arithmetic fact that 3 over 6 equals 5 over 10, and we get those numbers because 3 over 6 equals 5 over 10. We can substitute in the names of the segments instead of just the values of their lengths. So instead of 3, we write AB. Instead of 6, we write PQ. Instead of 5, we write AC. And instead of 10, we write PR. Then, because of the property of proportions, we can do a little cross multiplying and switch up the order. So that becomes AB is to AC as PQ is to PR. It's given that angles A and P are right angles, and angle A is therefore congruent to angle P because all right angles are congruent. And because of the side-angle-side similarity theorem, we can now determine that these two triangles are similar. Here's another proof of the side-angle-side similarity theorem. So, given these two triangles with side lengths as indicated, prove that they are similar. Alright, so we're given the triangles, and because of the segment addition postulate, we know that PS here plus SQ equals the full line segment PQ, and PT plus TR equals PR. So that's the segment addition postulate. Then we can substitute in the lengths instead of the names. So PS is 4, SQ is 7, PT is 8, TR is 14. And we can do that addition, and that's an arithmetic fact. And then this is another arithmetic fact that 4 over 11, which is 4 plus 7, equals 8 over 22, which is 8 plus 14. And then we can substitute back in the names for the segments as proportions here. So, and due to the property of proportions, we can do a little cross multiplying and rearrange them. So now we have PS is to PT. So this side here is to this side here, as PQ is to PR, so PQ is to PR. And then because of the reflexive property of congruence, angle P is congruent to angle P because they both have the same included angle, which is angle P. And therefore, the two triangles are similar. Here are the shortcuts for proving two triangles similar. AAA similarity postulate: if three pairs of corresponding angles in two triangles are congruent, then the triangles are similar. The AA theorem: if two pairs of corresponding angles in two triangles are congruent, then the triangles are similar. SSS theorem: if three pairs of sides in two triangles are proportional, then the triangles are similar. SAS theorem: if in two triangles two pairs of sides are proportional and their included angles are congruent, then the triangles are similar. Common error: you cannot prove triangles similar using side-side angle. This is not the same as side-angle-side. As shown below, two triangles can have two corresponding sides and one corresponding angle congruent, but not be similar. So if we slide this over, we can see that this is true. So even though there are two corresponding sides and an angle, because it's not the included angle between the two sides, like here, this does not work.